Now that we've had the opportunity to work with systems of equations, we're taking a little bit of a deviation still on the linear aspect of the unit, but getting away from systems and getting into arithmetic sequences and series for the next 3 days.
So the key vocabulary words again are arithmetic sequence, explicit formula, and recursive formula. So arithmetic sequence states this: a series of numbers that has a common difference between each of 2 consecutive terms.
The key there is common difference. Remember, difference means subtract, so either adding or subtracting to get from one term to the next, not multiplying or dividing.
Then we go on to explicit formula, which states used to find the nth any term in an arithmetic sequence. So the last term in the sequence would be Tn equals T1 plus D parentheses n minus 1. So the T1 is the first term, D is the common difference, and n is the number of terms.
So what's going to end up happening when you use this and find your explicit formula? It's going to come out into a format of similar to y equals mx plus b, except it'll be t sub n equals basically d times n plus some number, which would actually ends up being t sub 0, but that's not in your sequence.
And then we have the recursive formula, which states used to find the next term of an arithmetic sequence using the previous term. So first term, so T1 equals number. And then we go down to the next one, it says Tn equals Tn minus 1 plus D. So Tn minus 1 is the previous term, and D is the common difference.
Now this is the recursive formula is the one that a lot of you guys tend to struggle with, which is interesting because it's the easier of the two. This can only be used if you know a previous term or the first term, because you have to have that previous term to find the next term. It's as simple as you add that difference, whether it's positive or negative, onto the term that you had to get the next term, just like you would do normally when you're given the sequence. So what we're going to do now is we're going to start off by looking at finding the common difference and the next term. So when we look here, I look and see that to get from 1 to 4 is plus 3, 4 to 7 is plus 3, 7 to 10 is plus 3, 10 to 13 is plus 3. That means my common difference, or D, is a positive 3. If it was going down 3, it would be a negative 3. So then the next term in the sequence simply is going to be found by taking 13 and adding 3 to it. So we take 13 plus 3, which is 16. Not too tremendously difficult. Arithmetic sequences are pretty straightforward. Now, the second piece is being able to determine if a sequence is arithmetic or not. If it is, you got to be able to identify the common difference and the next term. If it is not, you have to be able to explain why not. So I look here, and from negative 4 to negative 8, I'm dropping 4 because I'm going more negative. If I'm minus 4, I go from 8 to negative 12, and you do need to check every term because I've been known to change one of them. And from 12 down to negative 16 is dropping by 4. So you would say yes, it is arithmetic, and D is negative 4. And then we've got here term 1, term 2, term 3, term 4. So term 5, or T sub 5, is going to be negative 16 minus 4, which is negative 20. For C, we've got 2, 5, 10, 17. And from 2 to 5 is plus 3. 5 to 10 is plus 5. 10 to 17 is plus 7. Now, while it's a consistent pattern of what it's increasing by, because that goes up by 2 every time, the difference itself is 3, 5, 7. It's not a common difference, so this one would be not arithmetic. And to be honest, to be able to explain why, your work right here explains why it's not arithmetic. Moving on, now you need to be able to find the explicit formula. So if you remember from the previous slide, T sub n equals T sub 1 plus D times n minus 1 is your explicit formula. So we look here and we want to identify our parts. So t sub 1, or term 1, is 2. We need to find the common difference. And so our common difference from 2 to 6 is 4, 6 to 10 is 4, 10 to 14 is 4, so our common difference is 4. We know that we're going to end up finding the 50th term, but remember the explicit formula is to find any term, so we do not want to stick 50 in for n yet. So that means that we've got term n is equal to term 1, which is 2, plus d, which is 4, times n minus 1. Now we just simplify. I see I can distribute here, so I get term n is equal to 2 plus 4n minus 4. And then I simplify to get that term n is equal to 4n, and then 2 minus 4 is negative 2, so my explicit formula is term n equals 4n minus 2. So now I can use that formula instead of having to keep on adding 4 each time, because yes, to find the 5th term, that's easy, but what happens if I'm tasking you to find, well, in the next one, the 50th term? I don't want to add 4 out to the 50th term. So what we do is we now say term 5 is equal to 4 times 5, because n is 5, minus 2. Well, 4 times 5 is 20. 20 minus 2 is 18. So term 5 is 18. Likewise, I can find the 50th term. So I can say, well, term 50 is equal to 4 times n, which is 50, minus 2. 4 times 50 is 200, minus 2 is 198 for the 50th term. The last piece, or sorry, second to last piece, is if I give you the explicit formula right here, 40n minus 15, we want to find the first 4 terms of the sequence. This is just as simple as it says term 1, so n is 1. So you're going to take 40 times 1 minus 15. Well, 40 times 1 is 40, minus 15 is 25. And then 40 times 2 minus 15. 40 times 2 is 80, minus 15 is 65. You'll notice now that it goes up by 40 each time, which you should have been able to tell from our explicit formula of 40n. That means that term 3 is going to be 105, and term 4 is going to be 145. If you can pick up on the pattern from the first 2 terms and want to just add on, you are more than welcome to do that. Otherwise, you would take 40 times 3 minus 15 and 40 times 4 minus 15. The last piece is I'm giving you the recursive formula, and I want you to find the first 5 terms. I filled in term 1 for you because it says right here, term 1 is 3, so we put that in. So then it says I need to find term 2. That means I'm going to take term of 2 minus 1 plus 4. Well, term 2 minus 1, that's term 1 plus 4. Well, term 1 we know from here is 3, so it's 3 plus 4, which is 7. Which tells me now I need to take term 2 plus 4. Well, term 2 we just found to be 7 plus 4 is 11. Then we take term 3 to find term 4 and add 4, which is 11 plus 4, which is 15. And then we take, to find term 5, we take term 4 plus 4. And it's not t times 4, it's term sub 4. And that's 15 plus 4, which is 19. So now that you've seen this, we got some U-try problems for you. The first one, I want you to tell me, is this sequence arithmetic? If it is, tell me what the common difference is and the next term. If it is not arithmetic, tell me what makes it not arithmetic. Then, I've given you an arithmetic sequence of 288, 238, 188, 138, 88, and I want you to find the explicit formula and the 30th term. And finally, if I'm giving you the recursive formula of t sub 1 equal to 7 and t sub n equal to t sub n minus 1 plus 6. I want you to find the first 4 terms and then the fifth, so basically the first 5 terms. And as always, make sure you bring in your questions or putting them into class meet, and we will see you in class tomorrow.